All right, welcome to another session of Krazifizix paper review. And just like we normally do, check on our website, krazifizix.org.za. You'd find more information about us. 0817442103 is what you can reach us on WhatsApp, calls, or SMS. Either as a school or as individuals, we'll be able to assist. All right. This is the face behind the voice. Again, my little introduction about myself. All right. My name is Kamalafe. All right. That's my name. All right. Popularly called Bishop of Krazifizix. I'd like to tell you where I am from. I am from Nigeria. All right, the blessed nation of Nigeria. All right, today we would look at paper 1. All right, this is the first section. We're going to look at question 1 to 4 in an hour. All right, it's May, June. All right, we're looking at physical science paper 1, May, June 2018. You can get the paper www.education.gov.za. Get the question paper, download, print, work through, and we'll guide you through. Now, question 1.1. The net resultant force acting on an object is equal to the dash. Go straight to your formula page. F net delta T equals to delta P. Divide both sides by the net force. Automatically, F net therefore becomes delta P over delta T. And every time you divide by time, we use the word the rate. So it is the rate of, what is this? Change of momentum. Wrong. Rate of change of momentum. Correct. Wrong there. We're done. Using your formulas to answer your question. 1.2. A physical quantity that is described as a measure of the resistance of a body to a change in motion. Resistance. Measure resistance. Now that is a definition from grade 10. That is our inertia. All right, that's grade 10, inertia. Quickly, 1.3. All right, the diagram below shows a section of a path of a stone projected vertically upwards. At which one of the positions indicated on the diagram will the magnitude of the momentum, what is momentum? From your formula page, product of mass and velocity. So when they ask you to define, use this to define product of mass and velocity. All right, one thing I need to know, okay, let's read on. At what stage is the momentum of the stone the greatest? Since mass is constant, it means what should determine the size of momentum is velocity. The question is, when do we have maximum velocity? Look at this object. Object is going up. At maximum height, it becomes 0, which definitely means it is decreasing as it's going up. On its way down, it's increases at point 3, but it becomes maximum at point number 4. So at number 4, velocity is maximum, therefore momentum is also what? Maximum. T. Because we said in one of our videos, we said we use Findo to describe a free fall. And what is Findo? All right, the velocity of an object will increase when it is going down. So when it's a free fall, if it's going down, the velocity does what? Increases. Going down, velocity what? Increases. All right, so the correct answer there is T. Beautiful. Question 1.4. All right, please, these videos are made to benefit you, so rewind them again over and over, all right, until you get it right. If there's any issue, send us an email, go to our page, drop a message, we would get back to you. 1.4. Two cars P and Q moving in a straight line having the same momentum. Okay, so momentum of P is equal to momentum of, momentum of P is equal to momentum of what? Q. That's what we know. The kinetic energy of P is greater than the kinetic energy of M. Okay, EK of Q is greater than the EK of P. Okay, let's try to solve this. Now, half MQ VQ squared. So can I write VQ should be greater than half MP VP. But we are told that momentum is equal, and momentum is mass times velocity. All right. So I can say this is half momentum of Q multiplied by the velocity of Q. This should be half momentum of P. But these and these are equal. So if we divide both sides, half. Okay, it means the speed of Q must be greater than the speed of P. All right, let's cancel out options. Q has a smaller mass, we're not sure yet. Same mass, we're not sure. Q is moving slower, no. Q is moving at the same pace, no. Okay, how then do we deal with this? If our velocities are different, it also automatically means that the masses are different. But momentum is equal. So momentum of P is equal to the momentum of Q. But if the velocity of Q is greater than the velocity of P, it means the mass of Q must be less than the mass of P. Let me use numbers to make this okay. Let's say the momentum of P is 12, all right, kilogram meter per second, which also means that the momentum of Q is 12 kilogram meters per what? Second. Okay, already we established that VQ is greater than VP. Let VQ be 6 and let VP be 4 greater. Now, how do I get momentum of Q? It's mass times velocity. 12 equals to mass times 6. The mass here is 2, mass of Q. Here, 12 equals to mass times 4. What is the mass of P? 3. Do you see the mass of Q is now less than the mass of P? Option A, correct. Beautiful question. I love it when we need to integrate numbers, integrate formulas. That is doing physics now. 1.5. The net work on an object, done on an object to increase its speed from rest to V is W. Okay, now it says the network, and we know our work energy theorem. Okay, I want to catch the 1 hour map that we have for every video. All right, now what's set from rest to V? It means my W, they said it's W, work net, half M, my final velocity is V squared, initial velocity is 0, which means W equals to half mv squared. How much net work must be done on the same object to increase? So my mass is the same. Its speed from V to 2V. Okay, let's check. Now, my new velocity is 2V. Remember, I have to square all of this, and my initial velocity is V squared. Okay, let's check. My W net now equals to half M 4V squared minus V squared. Somebody's saying why 4? This is 2V multiplied by 2V. Alright, so W net now equals to half M 3V squared. I want to rewrite this half M V squared, everything multiplied by 3. That's what it means. By the way, what is my W? Half mv squared. So this becomes W times 3, which is equal to what? 3W. There you go. C. All right, beautiful, beautiful, beautiful explanation, beautiful question. All right, that's it there. All right, so go through it, take notes, and try to understand what the whole thing is all about. Let's run to question number 1.6. Which one of the following is not an application of Doppler effect? All right, this is just content and remembering, recall. You must recall and understand the applications of Doppler. Blood flow meter is an application, Foitus is an application, speed of an approaching car. The one that is not an application is a light meter. We're done. That is content. Everyone should get that correct. 1.7. Two small identical metal spheres on insulated stands carry charge of negative q and positive 3q respectively. When the centers of the sphere are at a distance d apart, the sphere exerts an electrostatic force of magnitude F. The spheres are now made to touch and brought back to the same position. Now remember, when they touch, the shear charges to a point where they have equal. The magnitude of the electrostatic, so we're looking for F. All right, but before they touch each other, what's my formula? It's Q1 Q2 over R squared. Okay, my Q1 is what? Q, and this is 3Q, and the distance is T squared. So what do I have? I have 3K, Q times Q is Q squared over T squared. Okay, can we call this the F old, the original F? Now, when they touch each other, we have a new charge, return, Q1 plus Q2 divided by 2. And this gives us what? Q, negative Q, plus 3Q divided by 2. And that gives us a positive Q. Because 3 minus 1 is 2, divided by 2, we have 1. Now, my new force is K, Q over T squared, still using the same formula. So what do I have? KQ squared over T squared. All right, let's go check something. My F old is 3KQ squared over T squared. Now I want you to notice this. This is my new force. So can I say F, the old one, is 3F, the new one, but I'm interested in the new one. Can we divide both sides by 3? What are we going to have? The new force now is 1 over 3F of old. 1 over 3 P. All right, you must learn to work through your questions effectively. Okay, so that's the solution there. All right, rewind and check what we did, how we manipulate all our solutions quickly. Now let's go to the next question, which is question 1.8. Question 1. All right. In the circuit below, the battery has an EMF and an internal resistance of R. When switch S is open, readings are registered. Okay, please note, when the switch is opened, readings are registered. Switch S is now closed. How will the reading on the ammeter and voltmeter change? There's one thing I want to quickly teach you here. We did that video on electricity. Look for it. It's online. All right. We use the word revive to explain this. Revive. Don't mind the spelling. When resistance increases, or whether increase or decrease, it would answer the question. Okay, when resistance increases, what's going to happen? Current will decrease because they are inversely proportional. Now, according to Ohm's law, V internal will decrease because it is directly proportional to current, and V external will increase. This is to make sure that E is constant. Remember, E will not what? Change. Look, this is a sequel to most answers under electricity when we talk about resistors changing and not. But let's answer this question. If I close this switch, what happens here? They are connected in parallel. If it's parallel now, my effective resistance decreases. All right? It decreases because it's in parallel. So if it decreases, what happens? All our answer here would change. This one would be decrease, this one would be increase, inversely proportional, increase, and this one would what? Decrease. So ammeter reading will increase. We cancel these two. V external will decrease. My correct answer, it will not remain the same. All right. Electricity, very beautiful. You need to learn the revive thing. So you must know, if you are adding resistors in series, it will increase. Resistors in parallel will decrease. Now, question 1.9. Question 1.9. A learner lists the following as factors that affect the magnitude of the current induced in an AC generator. Look, this is grade 11. Induced. Faraday's law of electromagnetic induction says that E equals to negative N change in phi over change in time. Relationships. E is directly proportional to N. What is N? The number of turns of the coil. Number of turns of the coil. What is my change in phi? This is talking about the strength, the magnetic field. Strength of the magnetic what? Field. Strength of the magnetic field. And E is inversely proportional to time. That means if the time is short, or the time is short, EMF would increase, which means at high speed, EMF increases when the speed of rotation. Let's check. All the list. Number of turns, correct. Strength, correct. Speed of rotation. Which one of the following combinations below? 1 and 2 only? No, it's actually 1, 2, 3. So just go there and look for 1, 2, 3, and then you're done. Grade 11, bringing the concept into generators and motors, because this is the Faraday's law of electromagnetic induction. All right, question 10. The graph below is obtained from an experiment on the photoelectric effect. Now, many learners don't know how to interpret graphs. I'm hoping this video will shed some light for you. Now, this is a straight line graph, and from mathematics, our straight line graph is y equals to mx plus c. Now, what is the equation that we're dealing with here? Photoelectric effect. Work function plus kinetic what? Energy. Now, my aim, do you see my kinetic energy is on the y, and on the x is 1 over wavelength. I need to rearrange this equation in order to have that. So EK must come to where y is. Can I just bring this over here? And then I have E minus work function. Alright, so rearranging EK equals to E minus work function. Now there is a challenge. I have 1 over wavelength. Do you remember that this formula is on your formula page? I need that. So EK equals to what? HC over wavelength minus work function. Now I'm going to do a bit of mathematics rearrangement here. EK equals to HC multiplied by 1 over wavelength. Because this will still give me that. Y equals to mx plus c. Now what's on my y-axis? Kinetic energy. We're done. On the x, 1 over wavelength. We're done. Now what do you notice here? M, if I compare these two, M therefore is HC, and my C is my negative W naught. So what does it mean? The gradient is H times C. Which one of the following represents the gradient? Now what do you notice? My y-intercept is work function. Do you see it's negative there? There we go. Work function. So learn how to interpret these graphs. Please rewind the section, watch it over. It applies across so many things. All right. It applies across even electricity. A quick one, quickly. You have V there, and then you have I, electricity. E equals to I, R plus R. Okay, Y equals to mx plus c. Remember, my Y is V, and my X is what? I. Just a very sharp one quickly there. We need to rearrange. This is IR plus I times small r. This is V plus IR. What do we know? Can I rearrange? Bring this here. E minus IR equals to V. My V is done already. Alright. But on my X, remember, it is I. So I'm going to rearrange just by doing a bit of mathematics here. Let's start this way. These signs are not changing, remember. But because I want my I to be where my X is, I just replace this one here. Alright. Y equals to mx plus c. Do you see we're done? We have that, we have that. So under electricity, my gradient is negative R, which is internal resistance. My y-intercept becomes my EMF. So if you have a graph like that, negative gradient, V and I, this becomes your E, and this becomes your short circuit current. Okay. Watch out for our video on electricity. You'll get more explanation on that. Alright, question number 2. Block P of unknown mass. Please, when you read question 2, always note the forces. The mass simply talks about the weight. It's placed on a rough. That talks about friction. Horizontal surface. That talks about normal force. Normal force. Alright? Normal force. Alright, it's connected to a second block of mass. Again, we talk about the weight. By a light inextensible string, tension, passing over a light frictionless pulley as shown. Initially, the system of masses is held stationary, okay, which is 0, initial velocity, with a 3 kilogram block. 0.5 meters above, alright, that talks about delta y, not delta x. When the system is released, initial velocity is 0 there, right? Take 3 kilogram moves vertically downwards, alright, and strike the ground after 3 what? Seconds. Ignore the effect of friction. First question is to define acceleration. Guys, from your formula page, I hope you would remember this now. Vi plus a delta t. I want acceleration. Vf minus Vi equals to a delta t. Divide both sides by delta t. Now remember, when I say Vf minus Vi, it means change in velocity over change in time. What did we say? When we divide by time, it's rate. Rate of change of velocity. 2 marks there, and we're done. Now, it is important, guys, that before you calculate, draw your free body diagram. On P, what do we have? Alright, what do we have? We have our normal force. Please write in full. Normal. What do we have here? We have the force of what? Gravity. What do we have here? We have tension. Okay. And then we have friction. Now, since the object is stationary, my tension and my friction are actually of the same length. Alright? Friction. They are the same length. While the 3 kg, what do I have? Object is also stationary. What do I have? I have the force of gravity, and I have what? Tension. Alright. Now, let's look at the question. What do we need to do? Question says calculate the acceleration. We want the acceleration using equations of motion. Okay, let's go check. On the 3 kg, what do we know? The mass is 3. Initial velocity, 0. Time is 3 seconds. Delta y, 0.5. Guys, acceleration here, this is not a free fall. because there is tension. Tension, non-conservative force. Now, my equation that suits me here can easily be delta y equals to vi delta t plus half a delta t squared. 0,5 equals to 0 multiplied by 3 plus half a. Remember, this is not 9,8. It's not a free fall. So 0,5 equals to 4,5a. Please use your calculator. A now is 0,5 divided by 4,5, which is 1/9. And mathematically, A is 0,11. Please use your calculator. Meter per second squared. The question said magnitude, so we don't need direction. Number 2, 0.3. All right, this is 3 marks, so you have 1, 2, and then 3. Calculate the tension in the string. How do we calculate the tension? Again, my free body diagram. Since the object is now accelerating, what's my free body diagram? Object is accelerating downward, so my gravity should be longer. Okay, since we're just calculating, and that is tension. Now, object is moving down. Let's take downward motion as positive, and this becomes negative. What formula? F net equals to ma. I am looking for my tension, so it becomes Fg plus negative tension equals to ma. The negative comes from the fact that I've written it there. What is this? Mg minus tension equals to ma. 3, my g is 9,8. That's the weight. Minus t equals to 3 times 0,11. All right? 29,4 minus tension equals to 0,33. What do we do? Negative tension equals to 0,33 minus 29,4. All right? Use your calculator quickly. What are we going to get? 0,33 minus 29,4, we have 29,07. Negative 29,07. So T is 29,07 newtons. And that's how you work that out. How many marks are we looking at there? We're looking at 3 marks. Your formula gives you 1, substitution 1, and the final answer 1. All right, great. Let's work through the other questions very fast. I hope this makes sense to you. I hope this makes sense to you. Now, the magnitude of the frictional force experienced by P is 27. Let's try to see how to deal with that. Since I'm talking about P, draw a free body diagram. Do you see how our question is answered already? Okay, let's go redraw. Gravity, normal. Object is now moving. Tension must be longer than kinetic what? Friction. 1, 2, and 4. 1, 2, 3, and 4. Calculate the mass of block P. Guys, it becomes easy now. Object is moving in this direction. This becomes a positive and this becomes a negative. So F net equals to ma. Tension plus negative friction equals to ma. Do I know my tension? Yes, we got our tension earlier on. It was 29,07. 29,07 minus my friction is given 27. Mass and the acceleration is 0,11. Calculator quickly. 29,07 minus 27 would give me what? 2,07. 2,07. So we have 2,07 equals to m multiply. What we do, we divide both sides by 0,11. And what's our final answer? Our final answer is 18,82 because it's 18,82 kilograms. 1 mark there, 1 mark there, and 1 mark there again. We are done with question number 2, straight to the point. All right, easy to work through. If you're in grade 11, this is your question. If you're in grade 12, revise your Newton's laws. Okay. All right, now this question is vertical projectile motion. And let's see how to deal with this. In the diagram below, point A is at the top of a building. All right? Point A is at the top of a building. Point B is exactly halfway between point A and the ground. Between point A and the ground. Ignore air resistance. All right. Now, define free fall. I'm sure every grade 12 learner can answer that. A free fall is an object that has only the force of gravity acting on it. Okay, we don't want to waste time on questions like this. Force of gravity acting on it. You get your 2 marks and then you move to the next question very fast. A ball of mass 0.4 kg is dropped from point A. It passes point B after 1 second. All right. Calculate the height of the position A above the ground. By the way, we know that A to B is half of the ground. Okay, from A. What do we know? First, velocity is a vector quantity. Let's pick downward as what? Positive. All right, it's always easy. Downward as positive. What do we now know? Initial velocity is 0. That's what we're given. Let's calculate the distance between A and B because that's what I know. The time between A and B is 1 second. Okay, what else? A equals to what? Positive 9,8. And I'm looking for delta Y between A and B. Run to your formula page and check the correct formula that you can use. This is how to get your formula, all your data out, and then my formula becomes VI delta T plus half A delta T squared. Does that work? Yes. Delta Y equals to 0 times 1 plus half 9,81. And what will your delta Y be? 4,9 meters. But this is only between A and B. So delta Y from A to the ground is twice of this. 2 times 4,9, and that gives you 9,8 meters. Remember they said it is AB is half. AB is half. AB is half. All right. How many marks do we have here? We have 3 marks. 1, 2, and 3 there. Okay. Now, when the ball strikes the ground, it is in contact with the ground. It is in contact with the ground for 0,2 seconds. I'm going to draw a graph just later on now. And it reaches a maximum height of B. Calculate the magnitude of the velocity of the ball when it strikes the ground. What do we know? We're looking for VF. Now we know our distance between A and the ground as 9,8 meters. Acceleration is also 9,8 meters per second. What are we looking for? VF. We don't know the time. Please do not multiply this by 2. It's wrong. All right. VF equals to, okay, this would not work for us because we know VI. Okay, we're looking for VF, but what is VI? All right. So I cannot use VF equals to VI plus 8 delta T because I do not have time to scratch that out. Okay. VF squared equals to VI squared plus 2A delta T. I'm looking for the final velocity. My initial is that to 9,8, all right? When it strikes the ground, remember I am starting from my initial. Delta y is also 9,8. Now let's go to our calculator quickly. 2 times 9,8 times 9,8, what would that give us? That would give us 192,08. So VF squared is 192,08. But we need to find the square root of that. We need to find the square root of that answer, which is 13,86. All right, so VF is 13,86 meter per second. What are we looking for? The magnitude. So we don't need direction. 1, 2, and 3. So if you are marking, also mark yourself. Now, calculate the magnitude of the velocity of the ball. We just did that now. Now, calculate the magnitude of the average net force. Guys, when you see that quickly, go and check your formula for forces. But let me explain this question this way. This object reaches the ground, stays on the ground, and moves there. Velocity here is 0. Velocity here is 13, what was our final answer? 13,86. Velocity here is 0. Now I want to calculate the net force on the ground. Guys, I can think only of this formula. F net delta T equals to delta P, which is M VF minus VI. Now there is a problem. If I am look at where I painted with red. This is going to be my initial, but I need a final velocity. Now, this is why the examiner is giving 6 marks to this question. I need to calculate my final velocity first. How do I do that? Can we consider this section quickly? What do I know? All right. In this section, I do not know my final velocity. Object reaches maximum height, velocity is 0, and this is P, which is 4,9 meters, but negative now. Why is it negative? The object is moving. Because the object is moving up, we say it is negative. I hope you understand that. So my delta y is negative 4,9. Okay, remember my A is still 9,8. You don't change the sign. VF squared again plus V equals to VI squared plus 2A delta y. 0 squared because it's maximum height. Velocity unknown to 9,8 negative 4,9. Okay, let's go multiply quickly. What are we going to have? It's going to be 2 times 9,8 times negative 4,9. And what do we have? 96,04. So 0 equals to VI squared minus 96,04. Can we transpose? VI squared therefore becomes 96,04. And then we look for the square root of both sides, which is plus or minus mathematically. All right? Square root of my answer now, I'm going to have 9,8 meters per second. I'm quickly going to draw this diagram again so that we can see what this whole thing is all about. This object reaches the ground and goes back up. It hits the ground at 13,6 positive, because downward is positive. It leaves the ground at negative 9,8 after spending 0,2 seconds. Now do you see I can calculate my net force? Delta P equals to M VF minus VI. F net 0,2 equals to 0,4. That's the mass. Final value. Now, if I consider this initial and final, negative 9,8 minus 13,8. 0.86. Can we divide both sides by 0.2? Let's do some smart mathematics now. All right. So what is my net force? Quickly. My net force now becomes 0.4. We open a bracket, negative 9.8 minus 13.86. We close the bracket, divided by 0.2. And what's my answer? Negative 47.32. Negative 47.32. Now, what is the negative simply telling us? The question says average force exerted by the ball. Remember, force is also a vector quantity. So the ground is exerting a force upwards, but we said downward is positive, hence this must be negative. But for now, we are only interested in the magnitude. My answer therefore is 47.32 newtons. 6 marks. All right, that's vertical projectile motion. Let's run question number 4. All right. A trolley of mass 1.5 kilograms is held stationary at point A. Stationary. At the top of a frictionless track. When the 1.5 kilogram trolley is released, okay, we'll release it, which means V equals to 0 there, initial. It moves down the track, it passes point P at the bottom of the incline and collides. All right, collision there, momentum. Remember, it is still frictionless. Okay, frictionless. Use the principle of conservation of mechanical energy to calculate the speed. Now, what is the principle of conservation of mechanical energy? The principle of conservation of mechanical energy in an isolated system. What do we know? The total mechanical energy is conserved. All right. And what does that mean? It simply means that the mechanical energy at any 2 points remain the same. So EMEC at point A is equal to EMEC at point B. I'm going to try to work this out in 2 different ways. The same thing but 2 different approach. Now, what is kinetic energy? What is mechanical? It is the sum of kinetic and potential. All right. This is grade 10. All right, physics is very progressive. Kinetic energy is half mv squared, potential energy mgh, all at point A. Okay, now I'm going to use P because I'm looking for the speed at P. All right, equals to half mv squared plus mgh, all at point what? P. Let's substitute quickly. Half 1.5. Initial velocity released 0 plus 1.5. G is 9. Now, what is the height of A from P? P is my reference point, which is what? 2 equals to half 1.5. I am looking for that velocity plus 1.5 multiplied by 9.8. Now, what the height at P? I am at my reference now, 0. So this gives me a 0, this gives me a 0. Now, what is 1.5 times 9.8 times 2? 1.5 times 9.8 times 2. That gives me 9.4. All right, 29.4 equals to 7.5 V squared. What do? We divide both sides by 7.5. All right, and that gives us what? 3.92. 3.92. Okay, so my V squared equals to what? 3.92. But you know what we need to do when we find it as V squared? When we find it as V squared, what do we need to do? What are we supposed to do? We are supposed to find the square root. Okay, did we get all our parameters correct? Did we get all our parameters correct? Our mass is 1,5. All right. Now let's put it in our calculator. Okay, hold on. 1,5 divided by 2 should be 0,75. 0,75. All right, 0,75. So let's use our calculators properly. All right, that should be 0,75. All right, 0,75, and that answer should actually now be. Let's do that again, because we have changed the whole thing. 29,4. All right, divided by, remember we said 1,5 divided by 2 should be 0,75, 0,75, and that actually gives us 39,2. So v squared 39,2, and then we need to look for the square root of that answer. Square root of my answer now gives me 6,26. V is equal to 6,26 meters per second. All right, now let's try something else. Because this is an isolated system, it means there are no conservative forces. Now, what is my conservative force? There are no non-conservative forces. My non-conservative force is defined as FET. It's friction applied and tension. We did explain this in one of the videos. Find the video. I think it's the February March video. All right. Friction applied and tension. Since these forces are absent, it means that the work done by them is 0. So I can easily now say work done by non-conservative. The reason this formula becomes very easy is because in the formula page it's there, unlike the first one. Now change is v squared. Remember, it's always final. mgh final minus h what? Initial. Now this is 0. Half 1,5 v squared, initial here 0 squared, plus 1,5 9,8. What's my final height? It's at p. 0 minus 2. Okay, 0 therefore should be equal to 0,75 vf squared. The whole of this would give you negative 29,4. Already we are back at where we were. 29,4 equals to 0,5 vf squared. Divide both sides by that. If I remember, we got 39,2. The square root therefore is 6, what? 26. All right, yeah, 6,26 meters per second. Now both are the law of conservation of mechanical energy. Both are acceptable. All right, 4.2. I don't want us to waste time on this. It says the principle of conservation of linear momentum states that in an isolated system or in a closed system, what do we know? The total linear momentum is conserved. All right, so these are free conserved. These are free giveaway marks that we must quickly grab. 4.3. Calculate the speed of the combined, guys. When they combine together, automatically, okay, when the two trolleys collide, they stick together. That is an inelastic collision. When you see them combining together, it is automatically an inelastic collision. So, what do you notice? These objects were separate before and together after. So, if I say M1, M2, if they are together, I add the masses. Now, sum of initial momentum should be equal to sum of the final momentum. That's the original formula. I can now say M1 VI1 because they are separate. M2 VI2 equals to m1 plus m2 final velocity. Let's substitute. What is m1? 1,5. Initial velocity 0 plus what is m2? Oh, no, sorry, it's no longer 0. That's the mistake learners make as well. It's not 0 because it didn't collide here. It actually collided when it was there. And what is the velocity that we got at that point? 6,26. All right, 6,26 plus m2. It's at rest 0. Now what we do? We add plus 2,6. We're looking for the final what? Velocity. The whole, okay, now this would give you 0. What is 15 times 1,5 rather times 6,26? All right, that gives me what? 9,39. So 9,39 equals to, now what is 1,5 plus 2,6? All right, 1,5 plus 2,6, that should give you 4,1. All right, that becomes 4,1 VF. Now, what do you think we would do mathematically here? We just, all we need to do is to divide both sides by 4,1. So I'm going to have 9,3. Okay, sorry. 9. I need to clean that. Quickly. All right, 9,39 divided by 4,1. What's my answer? 2,29. All right, my answer becomes 2,29 meters per second. All right, that's actually very straightforward. That's very straightforward. Okay, but wait, my mass is 2. I'm sure someone is saying, why are we 2,6? Sorry, my mass is 2. All right. 1,5 plus 2 gives me 3,5 VF. Sorry about that. All right. So it is actually 9,39 divided by 3,5. My answer should actually be 2,68. All right. My answer, okay. It is important that we actually be more careful. 2,68 meters per second. All right. 4.4. The last question for us to deal with here. Calculate the distance traveled by the combined trolleys in 3 seconds. Now, guys, I am looking for delta x. Okay, let's go get space. Why delta x? Because it is horizontal. I'm looking for delta x. Now, time is given as 3 seconds. Now, what is the initial velocity? Because it says of the combined. When they combine, their velocity now is 2,68 meters per second. Now, guys, this is a frictionless surface. If it is frictionless, there is no applied force, there is no friction. It means this object will keep moving at constant velocity, Newton's first law. An object will remain at rest or continue in uniform motion unless an unbalanced or non-zero resultant force acts on it. Here there is no external force. So my acceleration becomes what? 0. What formula can we use here quickly? Delta x equals to VI delta t plus half a delta t squared. Now my delta x, what's my VI? 2,68 multiplied by 3 plus half. This is not a free fall, so be careful about that acceleration. Can we now just put all of this in our calculator? 2,68 multiplied by what? 3, because the other side will give me a 0, and my answer now is 8,04 meters. You get 3 marks. 1, 2, 3, and then we are done with question 4. This is where we are going to end the first session Please rewind and start all over again from multiple choice to question 4. We would stop here and then get part B and part C. Alright, get part B. If it continues, it will continue to part C. You will find out in the second video if it's actually continuing to part C. I always want to hit the 1 hour mark so that these videos are not too lengthy, hence the speed. Thank you so much for joining us. All right, thank you so much for joining us. I hope that you did get a whole lot of things from these classes. This is very, very important for us. All right, it's very, very crucial. Again, this is a presentation done by Krazifizix. Check our webpage, www.krazifizix.co.za. We would like to get a feedback from you. What can we do better to help you? Remember, this paper is May, June 2018 paper 1. This video is part A, question 1 to 4. We will start from question 5 in the next video. All right, thank you. And this is Bishop signing out. Krazifizix. See you later.